Good morning, guys. Here we are, Science Bell Work, Week 9, Day 4. Continuing that discussion that we've started on Monday with how can corn be yellow, white, or blue. Yesterday we kind of got into jumping genes. We've discussed DNA, traits, being inherited and passed down through animals. And now this week we've talked about how those same things can occur in plants. And today we get into selective breeding. So I will read through the passage, follow along, and then we'll move on to parts A and B. Genetic variation and jumping genes are only part of the reason that corn can be yellow, white, or blue. Corn was first cultivated in southern Mexico nearly 10,000 years ago. Ancient farmers used the natural variations in corn to create plants with the traits they liked through the process of selective breeding. They developed many strains of corn, including those that were yellow, white, and blue. Selective breeding begins when a farmer mates two closely related plants that both have a certain positive trait. From the offspring that are produced, the farmer again breeds the plants that strongly display the desired trait and prevents those without the trait from reproducing. Doing this again and again reinforces the trait in the offspring. So selective breeding, that's human-directed mating of organisms for desirable traits. Part A, explain in your own words how the process of selective breeding can be used to decrease the presence of a trait. So this just kind of summarizes what we just read. Let me get going here. So with selective breeding, you can breed only organisms with the traits that you desire, and you can prevent those same organisms that don't have traits or don't have desirable traits from reproducing, so that you can, when you're, whatever it is, whether it's corn or, you name it, you can breed those to have the traits that you want and also breed them to have the traits that you don't want. So over time, the undesirable traits will occur less frequently, to where you just they become obsolete. Okay. And B, grafting is a process that involves putting together part of one plant with part of another plant. One odd example of grafting is merging potatoes and tomatoes to grow on the same plant. Why do you suppose this plant must be grafted instead of selectively bred? Well, one reason is because potatoes and tomatoes are two totally different species. A tomato could never naturally produce potatoes and vice versa. So there you have it. There's your Science Bell Work, Week 9, Day 4. Hope you guys made your corrections and have a good day.